Hello boys and girls, today we're going to be doing part 2 of our volume lessons. It's calculating the volume of composite figures, and what we mean by composite figures is simply taking two or more simple three-dimensional figures and smashing them together. Last week we talked about volume. The formula for a rectangular prism is length times width times height. The volume for area is length times width. So what we do is we take a rectangular prism and we stretch it by its height. So now we have length times width times height. Another way to think about this, because next year you guys are going to be doing this with many other types of prisms, is the area of the base times its height. And so we have this rectangular prism. We take the length of 5, the width of 2, and the height of 2, and I multiply all those together and I get 20 cubic centimeters, or cm to the third power. So the thing is, reality check, the world is not made of just little rectangular prisms and houses, little boxes and stuff. It's made by many shapes being put together. So how do we calculate the volume of such things if they happen to us in a daily basis? And so what our problem-solving strategy is, we're going to break them into smaller, simpler parts. We have this figure right here, which has a lot of different measurements here. For me to figure this out would be very difficult just by looking at it. But what we do is we break it up into simpler parts. So what we have is actually, instead of one big shape, we have two smaller rectangular prisms. I'm going to draw a line right here so that you can see our two different boxes. They're represented as A and B from now on. They have the different shapes there. And what we're going to do is we're going to figure out what the dimensions are for A and for B. Well, we know the bottom of here is 80. Its depth or width is 10. And its height we still need to figure out. Now, if I know this height and I know this height together are over here, they both equal 60. And I know this one here is 40. If this is 40, that means this one would also be 40. That would make 40 plus what equals 60. The answer to that is 20. So now we have our dimensions for B. Let's figure out A. So if our total length in the bottom is 80 and this part right here is 60, that means it needs 20 more to make 80 on the top. So this width here, or the length, is 20. Now this height is 40, and if this depth is 10, then all depths or widths are 10. So now we have our dimensions there. Now we're going to calculate the volume of all those figures put together. So we're going to take our volume formula equals length, width, height, and we're going to do this for A. So we have a 20 times 40 times 10. Order doesn't matter in multiplication. So now we got 40 times 20, and that's going to give us 800 times 10 is going to equal 8,000 millimeters cubed. Important to remember that unit. Now for B, it's the same exact formula, so I'm just going to put those together. 80 times 20 times 10. And I break that apart. 80 times 20 is 1,600 times 10. Remember mental math. 8 times 2 is 16 plus 2 zeros. We get that answer. So we multiply that times 10 now, and I get 16,000 millimeters cubed. What we're going to do then is we're going to add those together. Remember, we're taking those parts and we're adding them together. So 8,000 plus our 16,000 is going to give us a volume of 24,000 millimeters cubed. So what that tells me is that this whole figure here with A on the top and B on the bottom, when I calculate them and smash them together, the sums of their volumes, I get 24,000 cubic millimeters. So here's what we did. To summarize, we take a big composite figure and we break it up into its simpler parts, the two rectangular prisms, or more. Next, we find the volume of each separate rectangular prism. Then we add those parts together to get the volume of the total composite volume. That's how we find the volume of composite figures.